Hello guys, now welcome to the next video in which we will be discussing the solution to the problem of minimum number of jumps to reach the end of an array. And I have seen many videos in which people lacked some sort of test cases which were not able to be passed. And this is problem from Geeks for Geeks. And I will be providing full solution with the approach using of time complexity big O of n. So let's start our presentation. So we will be talking about the two approaches, greedy problem approach and dynamic problem approach. So in this video I will only take greedy problem approach, not dynamic problem approach. We will be seeing it in the next video. So what is actually greedy approach? Greedy approach is checking the next best possible solution without knowing the end thing, that it will be perfectly right or not. It just focuses on the present. Like we don't know our next decision will be right for our end future or not, but we know that if this is the right possible solution which I can get right now, then it must be the best possible solution for the end also. It is basically nothing but an intuitive algorithm, and the best closest solution that seems to provide an optimal solution is chosen. Okay, so let me take you to the whiteboard and tell you what I am trying to say. Like suppose if I have to choose from values 2, 6, 7 and 9. Okay, so what we will do, just without any knowledge, what you will be to choosing, you will be choosing 9, because you know if I choose 9 right now, I will have more values right after that. Like in CGPA, what you do, if you maintain your CGPA this semester, then your next semester CGPA will be automatically controlled by you. You don't have to worry about it. So you check on the present solution, not on the anything else. You choose the locally best solution. Okay, and now let's talk about the properties. And we choose the locally best fit solution, and the optimal problem has optimal solution. As you have told you that if you maintain CGPA of this semester, then a whole semester, then a whole BTech CGPA or whatever course you are doing will be maintained simultaneously. Okay, now things you need to remember, that the solution you are choosing must be feasible. You're not choosing like randomly what you are choosing. It is not like that. If you wanted to choose, you wanted to go farther, you will choose the solution to farther one, not the solution to closest one. Okay, locally optimal solution, and how it is locally optimal solution I told you, and you cannot change the solution you have chosen right now afterwards. This is the things you have to keep in your mind. Now let's code the solution and go to our example. Okay, before coding, let's see the question what it is trying to say. We have given an array of length n. Okay, this is the array, and we have to move from this index to n such that we have minimum number of jumps. Okay, and this is the problem solution we have to find out. Now let us take this array only as a example to solve our problem on whiteboard, and let's discuss what this question is trying to exactly say, because this question is a little bit different from all the approaches. Okay, so this is the question. It is saying that suppose I am on this element. Okay, I want to go here but with minimum jumps. If in between I choose minimum number of jumps, then I will get the minimum number of jumps at the end also. From here, I have this value 1. So I can jump till the next number only. How I am choosing this? The index of I index of element plus the value at index. Okay, I'm choosing like 1 plus 0 equals to 1. So it can go till one index only. As you can see, this is 1, 2, 3, and so on. Okay, so this is the I can go till one index only. So I have no option but one jump. This is one jump I will consider. Okay, now here I have to choose the next jump such that it is optimal. And I will choose, I can go from here, I can go till value is 3 and index is 1. I can go till fourth index and this is still here. Okay, so how I am going, I have an option. If I go till 5, if I go jump to 5, then I will go till 1, 2, 3, 4, 5. This index, but it is not the end. So let us check if from 8 can we go to end. From 8 we can go to 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Yeah, we can go till the end from 8. So I will go to 8, jump to 8. Okay, and then from 8, I will jump till the end. The solution can be 8 or 9. It will hardly matter. We choose 8 or 9 here. Okay, so this is the problem what it is trying to say. It is trying to say that I have to jump. So here I have locally choose the best possible solution is 3. We have no options, so we have to choose 3. But here the best possible solution can be 8 or 9. We can choose anything. Okay, so here I choose 8 or 9 and then jump till the end. So this is how the greedy approach is working. We are choosing the best locally possible solution. We are not considering the last, but we are choosing this. And we are choosing the farthermost which can go. And how we are choosing farthermost? By this formula. Index of the element. Okay, so let's go to our Eclipse. Let's go to GFG only and practice code their rule. So you can see that the solution is accepted also. Okay, so the base condition will be that if our array at 0 is equals to 0, then we will return minus 1. Minus 1 because we have no solution to the problem. Minus 1 jumps. Okay, and from here we will take a variable current end. What is current end? It is the value till which I can check out this. This is current value is what? From here I can go till here and I have to choose best possible solution within this only. So this is the current end is. Okay. Current end initial conditions I will take it as 0 only. Sorry, index 0 1. Current, then I will take current answer. Current answer will contain nothing but the farthest most value, and we will take jump. Initially we will take jump 1 because the minimum 1 jump is there. And how we get to know? Because of we have checked that this is not 0. So there will be some jump. Okay, and that jump we will consider it because this is not 0. We have checked it. Okay. So we will make a for loop for int I equals to 0, y is lesser than array dot length I plus plus. So here we will not start with 0 because we have taken 0 condition here. So we'll start from 1 and we will check if what we will check that if we will check that if I is lesser than current end or not. Okay, we will check. And in that we will find the most farthest value. So this will be current answer, which is math dot max current answer comma ARRI plus I. So what is this? This is the formula that I wrote here. That how far the farthest most thing it can go to from 8 till where it can go. The maximum of element with which can go to farthest most point will be considered from the solution. Okay, so this is the main thing of algorithm, and if it is not, and we will check if I is equals to current end. Okay, we'll check this. If it has reached till the current end, then what we will do, we will make our current answer current end as the current answer. What we are making, see here, we have let me just, what it is doing, suppose I have reached here. Okay, then the value it can be 4, fourth index I can go till. And if I have gone and I have found the maximum farthest is 9 1, then we'll go to the maximum farthest value. Okay, if I have found, I will make this as a current end, and end current end I will make it. Okay, this is the thing here. Then we will also make jump increment because we are jumping. Here you can see I have reached here, so I will jump here. I will jump here. And what I will do, I will make current answer as -1 so that there is no chaos in the answer. Now I have done all these things, but I have not considered one thing. But the condition I have not considered is when, suppose I take a question, a test case of GFG only, which was not being able to pass, and that was 2104. If you see in this problem solution, if I go to 2, then I can go till index here. In the greedy solution, 1 will come. But after 1, I will only get to choose 0. And the answer should be -1. Where is this condition considered? This condition will be considered C. If you see the for loop will go when I will check for the current index till here, then the for loop will reach here at the end. But our current answer has not reached. So this the gap will be considered as a new. This gap we will take as a new condition. Okay. Or we will take that if I is greater than is equal to array dot length -1, and our current end end is greater than or equal to array dot length. Okay, or we can say current dot length or -1 we can say, because you have taken here also. Also here we will take equal to only because it is at the end, and if this condition is satisfied, then only we will return jumps, this condition, and at the end we will return here -1. So let's check if our answer is right or is there any flaw or something. Let's run it. for the test case first before submitting. Okay, it is saying jumps. Okay, sorry. Let's run again. Yeah, you can see here the test case is this and the output is 3. So let's submit our problem and see if it is correct or not. Yeah, as you can see, this is correct answer and execution time has been completed within the given constraint, and as you can see we must have taken expected time complexity as big O of n. So let's move to our PPT. We have coded greedy approach time complexity. As you can see, we have taken only a for loop and nothing else inside it, only the conditions to check. So this is big O of n only. Under space complexity, you can see we have taken only variables and no additional array or dynamic something that can be considered into something or something. Sorry, into the space complexity. Dynamic. Yeah, very soon it will be there. Thank you guys. Thank you. And if you have any doubt, please comment down below or any sort of problem in any test case you find. And this is the recent solution to problem from 17th June 2021. If there are any upgradation in the test case or solution, please let me know so that I can update and make new video on it. Thank you guys. And remember that dynamic approach will not contain big O of n, it will be big O of n square, but still I will take out the video on dynamic approach when we will be on our as our DSA course is on the way and we are on the part of sorting. So as soon as the sorting will be finished, slowly we will take towards dynamic approach also solution, so that basically I wanted to take only those solutions which are feasible and marking on the competitive coding sites. That's only I will make it soon. Thank you guys. Thank you. If you liked it, please share it with your friends and bye guys.